Alrighty, we are on our last section of the chapter 8.6, questions given logarithmic equations. So, sometimes performing regression is super useful. Sometimes it's also useful just to sketch a graph or to interpret it given that graph and a situation. So that's what we're going to work on today. We have a couple of examples to get through, and then that's it for chapter 8. Whoop, whoop. All right. So the average height of a human in feet over time in years can be represented by the question below, or the equation below, where h is going to be your height in feet and t is going to be your time in years. So before we even graph anything, what are some restrictions that exist? Well, for height, it can't be negative, right? We can't have a negative height. We could have a height of 0. We could have a height of anything greater than that, but we can't have a negative height. So h has to be greater than or equal to 0. And same thing with time. Our number of time in years has to also be a positive value. So it has to be greater than or equal to 0. So we could have 0 years, but we can't have 0 as, or negative values as our years. So height and time cannot be negative. All right, so next question says, sketch a clearly labeled graph of the equation below. So again, before we even start anything here, let's start giving our graph a title, maybe label some axes and things like that. So our graph is representing the average height of a human over time. So that can be our title. So average human height over time. Then we have to figure out what's our independent variable and what is our dependent variable. We have time and we have height. How tall you are is based realistically on how old you are. So time is going to be our independent, and time is given in years. And height is going to be our dependent, and height is given in feet. Okay. So we can't figure out our scale yet because we don't know what our graph quite looks like. So I'm going to open up Desmos here and go ahead and plug that in. So 1.75 plus 1.2 ln of x. I like to always still plug in x where our independent variable goes and y where our dependent variable goes. So I could have done y equals. Here it won't change anything. And it doesn't say how much we have to graph here, but what I'm thinking is maybe let's do a decent amount of years. So maybe let's do x is equal to 5. Let's maybe go up to 20. So x is equal to 10. Just get some key points here. X is equal to 15. X is equal to 20. And then graph kind of those coordinates there. And get that intercept. Okay, so that's what we're going to graph. Because the question doesn't specify over what range we have to sketch that graph, realistically it's up to you, but it is smart to have at least, I would say a bare minimum, 3 points that are labeled so that you can connect the dots reasonably. Okay, so I'm going to just zoom in on this side here. Notice that for my scale, I'm going from 0 to 20. So, maybe I'll just keep that in green here. So 0 and 1, 2, 3, 4, 5. 1, 2, 3, 4, 10. 1, 2, 3, 4, 15. Oh, I think those last sections were a little bit bigger. 1, 2, 2, 3, 4, 15. 1, 2, 3, 4, 20. Ah, you're right. It doesn't look great. Let's try it again. maybe if I just go up by 5s. 5, 10, 15, 20. I think that looks better. 5, 10, 15, 20. Okay, and if I'm looking, my largest height in that range goes up to 5.3. So as long as I get over 5 on my y-axis, life will be good. So I have 1, 2, 3, 4, 5, 6. And that should give me enough there. So 0, 1, 2, 3, 4, 5, 6. Perfect. Now, I'm going to go ahead and plot these points that I have. So my x-intercept is 0.233. So I'm going to go ahead and plot that. What might help, especially if you have those decimals, is at least for the first guy, kind of draw in your ticks so that you have an idea or a better idea of where that's located. I'm even going to label the point, and like I said, it's good to label at least 3 points here, just so that whoever's looking at your graph understand what you're trying to portray in terms of information here. So here we have 5 and 3.68, so 5 and 3.68 will be somewhere around there. So 5, 3.681. We have 10 and 4.5, 10 and 4.5, 10, 4.513. We have 15 and 5 on the nose there, so 15 and 5. And last but not least, we have 20 and 5.3. 5.345. All right. And with this, we can kind of connect the dots here and draw a smooth kind of logarithmic curve. Notice that on this side, we are going to draw an arrow because time and height can both increase. But on this side here, we are not. We are drawing a firm point, right? Because that is based on the limitations we introduced in part 8. Height cannot be less than 0, so we are not going to have values go this way. And we cannot have time less than 0, so we're not going to have values that way either. So, something to just keep in mind is when we're talking about word problems and drawing in those graphs there, we aren't going to continue on with the graph if it doesn't make sense to do so. All right, from here we just have our basic questions like we normally do. What is the estimated height of a person when they turn 15? Well, when they turn 15, the x value is going to be 15. And our y value, we actually already plotted that one, so that kind of works out. Y is equal to 5. So we expect them to be 5 feet tall at age 15. And this is the average height. All right. The next question. A logarithmic function can represent the average height of a human, but it has limitations. Explain why the domain and range is limited in this situation. Okay, so it doesn't ask us what the domain is and the range is, but it's asking us why is this limited? Why can't we just continue on with this graph? So a couple of things, we'll break it up into domain, we'll break it up into range here. And so domain is talking about how old someone is. So first of all, the domain is restricted because what we've already talked about, I'll just close this a little bit, because a person cannot be a negative number of years old. But in the other direction, a person could not live an infinite amount of years, right? If we continue on this graph to the right-hand side, that means our time is increasing and increasing and increasing and increasing. Well, a person doesn't live forever, right? Eventually, there is a time in which that person will pass on, they'll eventually die. So our graph is limited in that perspective as well. So it's restricted because the person could not be a negative number of years old, but also because humans don't live an infinite amount of years, or infinite number of years. They eventually die. Alright, so that is why our domain is restricted, because our domain was talking about the number of years of a person. But our range is also restricted, right? So our range is talking about our height. And again, we've already mentioned one restriction that exists on our height. Our height can't be negative, right? So our range is restricted because a person cannot have a negative height. But also, right, in our range of a regular graph, we would say that our range would continue to infinity. But if we're talking in terms of height, I've never seen a person grow an infinite number of feet tall, right? Eventually, people stop growing. So, person can't have a negative height, but also people eventually stop growing. Height cannot be infinite. So if we're talking about our domain and our range, yes, there are some very obvious restrictions in the sense that height and time cannot be negative. But we could also think about restrictions on the other end as well. In a situation like this, we can't determine the domain and the range. All we could say is that restrictions exist, right? Because every human will live for a different amount of time and will have a maximum different amount or different height. So we can't physically write down what the domain and the range is, but we can say, you know what, these restrictions exist, so we can't continue looking at this graph forever because it doesn't necessarily represent the situation perfectly. It's just an idea of how the trend continues. All right, we have one more example. The euphotic zone is the upper 200-meter layer in an ocean. Very little sunlight penetrates deeper than 200 meters. So most plants live in the euphotic zone. First of all, most plants live in the euphotic zone. As a result, 70% of all photosynthesis on Earth occurs in the euphotic zone of the oceans. The percentage of penetration of sunlight, represented by the capital P, in relation to depth, d, in meters, can be represented by the equation below. Okay. Use the equation of a logarithmic regression function to determine the amount of sunlight that penetrates to a depth of 200 meters at this location. Express your answer to the nearest 10. All right, we're going to clear out Desmos here. Bye. I'll maybe open Desmos a little bit larger, and I'm going to plug this in. So y equals this minus 200.84 ln of x. All right. And we can see, if we start zooming out here, we can see the different, or that logarithmic curve that we normally do, which is great. We have, in this case, our The percentage of penetration of sunlight is represented by capital P, represents our dependent variable, and our independent variable is our depth, our lowercase d here. Okay, so we want to figure out the amount of sunlight that penetrates a depth of 200 meters at this particular location. So we want to figure out when d is 200 meters. Or we could say when x is 200 meters. That's what we're plugging into Desmos here. So we plug in x is equal to 200. And we go find our intercept. We get our y, or our p-value, as 1.513. So at this particular place, because we're answering to the nearest tenth, we have 1.5% of sunlight penetrates at this depth. So if you are 200 meters below the ocean surface, you will only see 1.5% of sunlight that you would see at that surface. Okay. At what depth would the light no longer be able to penetrate that surface? Is the next question that we have here. We'll just box this final answer. So we want to know when light will no longer be able to penetrate the surface. So we want to find out when P is equal to 0%, right? Where there's no more light able to penetrate that surface. So that's essentially us plugging in y is equal to 0 into our equation. And that is finding our x-intercept here. So we will be able to find that no sunlight is able to penetrate at the depth of 215.061. And we could write our final answer to 2 decimal places because it doesn't tell us otherwise. So 215.06 meters. So if that's how far you are below the ocean surface, you will no longer be able to see any light go through, which is kind of insane. All right. A good logarithmic equation is a good representative of the percentage of sunlight that penetrates at different depths of the ocean. However, there are limitations. What are the limitations on the domain and the range? So similar question to before, and we will break it down. And in this case, we could actually figure out the domain and the range, so we'll kind of do that at the end there after we figure out what the restrictions are. So the domain in this case is talking about the depth, so the depth of the ocean. So what restrictions exist on the depth? Well, first of all, we can't have a negative depth, right? How deep is the ocean? Oh, it's -5 meters. -5 or negative any number doesn't make sense in that context. So first of all, the first restriction is that the domain is restricted because we cannot have a negative depth. Because contextually that just doesn't make sense. But on the other end, right, because depth could be 0, it could be larger, but we can't have an infinite depth either, right? At some point, you're going to hit the ocean floor. The ocean doesn't go on forever and ever and ever and ever and ever. At some point, you will hit that ocean floor. And let's see, the domain is not infinite, as eventually you will reach the ocean floor. All right, so we've kind of narrowed our domain down on either side. So our domain, our depth cannot be negative, but it can't be infinite as well. Depending on where you are at that ocean, you will eventually reach some sort of end point. In terms of our range is our percentage, right? So, well, it's a percentage of sunlight that penetrates that ocean at that particular depth. But for our range, It's restricted because we can't have restricted. Because you can't have a negative percent, right? You can't have a negative percent of sunlight that's able to go through that ocean. So it's restricted because you can't have a percent. But also, it doesn't make sense to have more than 100%. How could you have more than 100% of light penetrate the ocean? So the range is restricted because you can't have a negative percent, but you can't have a percent greater than 100 either. Right, so our domain is pretty set in stone in the sense that our range is pretty set in stone. It has to be from 0 to 100. There is no if, ands, or buts, right? You can't have a negative percent, so the smallest percent you could have is 0, and the largest percent you could have is 100. With that being said, because there are definite restraints on our range, our domain has to follow suit. I'm just going to X this off. So if our smallest is y is equal to 0 and our largest is y is equal to 100, the only parts of our graph that make sense are from here to there. Okay? Which means we can also see that our domain can only be between those two values as well. So our smallest domain is going to be 1.773, and our largest domain is going to be 215.061. Okay. The question did not ask for us to tell the domain and the range of this particular example, but I just wanted to show you that if we can see the restrictions on one of our domain or our range, and those restrictions are pretty clear and concise. They're not saying, well, it can't be forever, but it could be for a long period of time, right? We can use those concise restrictions to then impose on our other axes. So our range had these clear restrictions, and then we could impose those onto our domain as well. All right? All right, that's it for the unit. You have a little bit of homework to give a try. You only have 2 questions, which is pretty dope. But other than that, adios, muchachos. Good luck.